Alright, welcome to word problem clips. These will be short and straight to the point. If you have any questions, you can leave a comment and I can post videos on theory if there's anyone who is interested. But as most of these theories have been done to death all over the internet, you could easily find anything you need to know prior to watching this video somewhere else on YouTube. So this problem here is a calculus problem. And if you're looking in a textbook, you'd find it in optimization, or it's right after derivatives and right before integrals and next to related rates and all that, but it's applying extrema. Okay, so if you don't know those concepts, go ahead and find another video to learn about optimization and calculus, first derivative tests and those things, but come on back when you know how to do that. So we're going to prove that a rectangle of largest area having a given perimeter P is a square. So rectangle looks like this. We'll call this the base and this the height. Doesn't matter what we call them. It says we have a given perimeter. We know what it is. It's like writing a 5 or something. It's not 5, it's P, but it's like writing a 5. We know what it is. And that'll be the sum of the sides of the rectangle. So B plus B, or 2B, H plus H, or 2H. We know what this is. Okay? Now, this was perimeter. The other topic here is area. Area of a rectangle is equal to base times height. In these types of problems, optimization problems, or applications of extrema, you're looking to solve for one variable to plug it into the function that needs to be maximized or optimized. So we need to solve for either B or H in the perimeter equation and plug that value into this formula here in either spot depending on which one we choose. Notice we don't add a new variable to the picture because P is not a variable. It says it's a given, so we can pretend it's anything. We know what it is. So here we go. I'll label these 1 and 2. Equation 1. Perimeter is equal to 2 base plus 2 height. And I don't know, let's solve for base. So 2 base, subtracting 2h from each side, 2 base is equal to perimeter minus 2 height. So dividing each side by 2 or multiplying each side by 1/2, which is really the same thing, we get B is equal to 1/2 P minus H. Alright, so now we have the function we need to insert into our area function. So we can actually use calculus because right now we have a little problem. It's in terms of 2 variables, but now we could have it in terms of 1. So here, start working with equation 2. We get area of a rectangle is equal to base, B is equal to this. So we're going to say base, which is 1/2 P minus H, times height. And this is base. And now we have one variable. So this is really area in terms of height. So if we want to know the extrema, or the maximum spot right now of this function, if we look at graph of it, it's going to be, in a sense, concave down or convex. And there will be a point on the graph when you graph it, and this line doesn't really mean anything, by the way, but there will be a point in which the slope goes from being positive to negative, and at that point the slope of the tangent line is equal to 0. And this spot is a maximum because no spot can go above it at all. So it's a maximum. Now, derivative, when we take the derivative of A with respect to H, and we set it equal to 0, we're trying to solve for the values of h in which the slope, or the rate of change, is equal to 0. So that's what we're going to do. We're going to take the derivative of a with respect to h, and I'm going to simplify this over here so it's easier to see. 1/2 p h minus h squared. Okay, so we're taking the derivative of this. Alright, so the derivative of 1/2 ph is 1/2 p. Remember, we know what p is, so it doesn't act like a variable, it acts like a constant. And then we take the derivative of the second chunk here, which is minus h squared, and we get minus 2h. And if you're fuzzy on derivatives, then you need to, it's just been done to death all over the internet, so I'm not going to do any tutorials really on calculus unless there's interesting things or interesting proofs that I find. So anyways, let's continue. So we know the rate of change of area with respect to the height is equal to 1/2 p minus 2h. So in other words, we have a function for the slope. This is like a slope function. At any point it'll tell us the slope. If we plug in an h here, it'll tell us the slope on this function at that point. So we need to know when the slope is 0. So we'll set it equal to 0. 1/2 p minus 2h is equal to 0. Okay, so now all we have to do is solve for h. I'll just move h to this side, so we get 2h is equal to 1/2 p. Divide each side by 2, or in other words, multiply by 1/2, but it's the same thing. You get h is equal to 1/4 p. Okay? Alright, so that doesn't really prove it's a square or anything, but we do have a value now that we can plug back into our perimeter equation in order to solve for b, because we know what p is, so this is known completely. We know what this is. Alright. Alright, so let's plug in our value of h here, 1/4 p, into this expression. So p is equal to 2 base plus 2 times h, which is 1/4 p. Which, simplifying, we have 2b plus 1/2 p. So p is equal to 2b plus 1/2 p. Well, we can subtract 1/2 p from each side, and if this is 2/2 p or 1 p, we find that 1/2 p is equal to 2 times the base. Now we multiply each side by 1/2, or divide by 2, and we find that base is equal to 1/4 p. So now we know what the base is. So what we do from here is we look at the relationship of a square. So in a square, all the sides have the same length. So in other words, the base would be equal to the height. Well, the base is equal to 1/4 p. The height is equal to 1/4 p. So 1/4 p is equal to 1/4 p. So the base is equal to the height. So we have just found that the largest area of a rectangle with a given perimeter p is a square. So there you have it. We proved that a rectangle of largest area having the given perimeter p is a square, because a condition of a square is a rectangle in which the base is equal to the height. And when you solve for the maximum of this function, you find, yes, that indeed the base is equal to height at the maximum area. That's it, folks. I hope you tune in for more videos coming soon.